Hello and welcome to Xamarin University, and thank you for joining me here today for this recording of XAM330. My name is Adrian Stevens, and I'm going to be talking to you about Xamarin.Forms effects. Now before we jump into the specifics of effects, I'd like to explore the options we have for customizing our control appearance on Xamarin.Forms. Now, Xamarin.Forms makes the process of creating the application really easy by allowing you to define the UI once and share that definition with different platforms. And as you've seen, it utilizes the native platform's controls to render your UI, and that's fantastic. And the Forms development team has done a great job and try to make the app look and act reasonable on each platform, using each platform's specific paradigms properly and taking advantage of the platform control capabilities where they can. But the look and feel can tend to be just a little bit generic, and sometimes there will be small areas where it just doesn't look quite right, or where Xamarin.Forms doesn't let you influence the native control. As an example, disabled buttons on iOS change the text color, and you can't control that directly in Forms. Our goal is to quickly look at moving outside of the shared definition and to peek under the hood at how Xamarin.Forms renders controls and what we can do to alter that behavior. Now first, recall that we define our UI using shared elements. As an example, here is the button class that we use to define a button in our UI. But these controls are not visual. They're really placeholders for what we need to generate. And at runtime, Xamarin.Forms will create a platform-specific control for each of these elements. Now for most elements, we can customize the appearance of the generated control by setting properties. And where possible, the platform control will be adjusted to respect those property values. So think of elements as platform-independent models, which represent the control that we want to generate at runtime. Now with these properties, we can change the most common visual things. So background and foreground colors, position and sizes, font families and font sizes. But it's not complete. All three platforms have well over 30,000 APIs available to them, where Forms has about 2,000. And that means that our ability to customize the application is limited to core common features. Sometimes you can get the effect you want by changing a Forms property, and sometimes you'll find that it's just not possible to change a visual within the scope of the API provided by Xamarin.Forms. So when you hit one of these areas, you've got a couple of choices. You can just live with that restriction and decide that it's good enough. Or you can try and twist Forms to your will by taking over part of the native rendering process. And that's what we're going to focus on here. But to see how to control the rendering, we have to go a little deeper into the architecture. I mentioned earlier that Forms will take our element definition and turn it into a native control. So for example, our button element will turn into an Android widget button on Android, a UIKit UI button on iOS, and a Windows UI XAML controls button on Windows. Now the code that does this is called a platform renderer, and each element that you work with in Xamarin.Forms has a unique renderer assigned to it that takes your element instance and creates a unique platform-specific native control to represent it on screen. These renderers are by nature platform-specific. So here you can see that we have a unique renderer object defined for each of our supported platforms. We're showing 3 here, but there are also renderers specific for Windows Phone and Windows Desktop, which are also supported platforms. Now when you add the Xamarin.Forms NuGet package to your app, recall that the platform projects get an extra platform-specific assembly. And most of this assembly is made up of these renderers, which are unique to that platform. Now the second job of the renderer is to manage the notifications from the native UI control that it created and forward those notifications up to the element. So as an example, if you tap on an iOS UI button defined in Forms, the button renderer will handle the touch-up inside notification and pass that up the chain to the Xamarin.Forms button element, where your code can handle the clicked event. We can actually gain a little bit of insight on the rendering architecture by exploring a Xamarin.Forms application, or more specifically, setting breakpoints on the event handlers on our elements. Here I've got a default Xamarin.Forms application with just a slight change. In the default content page, I've replaced the label with the button. In the code behind, I've wired up the clicked event to an event handler, and we've added a breakpoint. So let's run this on Android. I can hit the button, and we see the breakpoint, and we can see our on button click being raised, but look down the call stack. You can see this is actually coming from our Android button renderer. We can see the same thing in iOS. I'll hit the button, we'll hit our breakpoint, and again, examine the call stack, see it's coming from our iOS button renderer, and there's our touch up inside call. So now that we understand how the rendering system works, let's talk about how we can influence it. And there are three dominant ways we can control the native control rendering. First, we can take advantage of the platform's theming capabilities. All three platforms support the ability to define an application theme, and this dictates common colors, fonts, and other visual characteristics. And it's a little bit different on each platform. Now, some of this we can control on the element, but if we wanted to set up an app theme unique to a platform, it would be better to use the platform-specific theming capability instead of setting those colors in the shared definition. Now, second, Xamarin.Forms has an effects API, which allows us to add code to the renderer used to create the native control. And we can define unique effects that apply to a specific element, or define effects that can be used with any element. This feature is very powerful, and if you're trying to change a property on the native control or hook into a feature of the native control that's not exposed by forms, this is likely how you'll go about doing it. And for visual tweaks or improvements, 90% of the time, an effect can do what you want. And we'll look at these more closely in just a moment. Now finally, we can actually replace the renderer with our own renderer. This allows you to take complete control over the rendering process. So you can create a completely different control for an existing Xamarin.Forms element, or you can define new elements with new renderers, allowing you to create fully custom controls that don't currently exist. This is a complex topic, and Xamarin does have a lot of documentation around this. We're not going to look at this today, but you should be aware of this as a possibility if you want to completely change what control is generated. And watch out for Xamarin.331, our upcoming class on Xamarin.Forms renderers. Now, if what you want to customize is colors and fonts and spacing of the controls unique to a platform, then you should first look at the theme capabilities. Keep in mind that Xamarin.Forms has a style API as well, so if you want the app to look the same on all platforms, you should look at that feature first. But for platform-specific changes, you can use each platform's theming capability. On Windows, this is encapsulated in the Style and Control template APIs. Now, since Forms is creating native controls, you can define global styles in your app XAML in the platform-specific Windows projects, which will be applied to each of those controls. This will let you change selection color, hover effects, or even completely replace how the control is rendered by assigning a new control template within a global style. Now again, this is not Xamarin.Forms XAML. This is Windows platform-specific. The Xamarin.Forms label renderer creates a text block in the Windows platforms, and we can use an implicit style that targets text blocks to control the label. Now on iOS, you can use the UI Appearance API to establish default property values for almost all UI view types. So you can apply this in your app delegate code and it will ripple through your UI definition. And on screen here, you can see we're changing colors of the UI switch, the UI slider, and even the UI navigation bar. This is a very powerful and very easy API to work with. And finally, Android defines themes which can be applied to your main activity, which is then used to host your Forms visuals. The theme dictates the colors, whether you have an app bar, even controls the fonts for the application. Now, as of Android 5, or Lollipop, there are 3 built-in themes defined, and you can derive from those and create new custom themes. Themes can be applied at application level or to specific activities, and it's really not too much work to create a custom theme that derives from the defaults. And we'll see that in just a moment. Let's try out some of those platform-specific theming options. I've opened up a Xamarin.Forms application, and this is a single screen application with a number of controls added to it. And we see it here running on the iPhone simulator, and we have a label up top. a switch, a second label, a button, and a slider. Now, in Xamarin.Forms, it's not possible via the Xamarin.Forms APIs to change the switch background color or the track color on the slider. But we can do it in iOS using the Appearance API. And we'll do this in the iOS head project. And I've opened up the app delegate, and we can set some global properties that we apply to all instances of controls in our iOS head project. So for example, if I want to set the switch background color, I do UI switch.appearance, it's static and has an on tint color property. And I can simply assign this a color. Again, this is platform specific, so we're in the iOS world now, we're in UI kit, so we'll use a UI color, and let's set that to orange. And let's also set the track color for our slider. So UI slider, very similar process. Appearance, and let's do minimum track tint color, and let's do that let's do red. And we'll do the maximum as well to get the other side. And so these will be applied globally, and these will be applied to, so every instance of a slider will have these colors, and every instance of our switch will have these colors, it's very much a theming option. It'll give a consistent look to our application. Let's try this out now. And now we see the app again, and we see we have our orange background on our switch, and we have our two track colors for our slider. And of course there are other properties you can set, and every control in UI kit has tint properties, and so we can do customizations on things like navigation bars or other controls, even control font sizes and font appearances on various controls. It gives us a lot of flexibility, and there's a lot of theming we can do on the iOS side. And this will apply specifically to the iOS implementation when it runs on the iOS platform. So let's switch over to Android now and see what we have for our Android projects. And to do that, I'm going to open up the main activity in our Android head project. So I'll first run the application as is on Android. And we see our application again, and we see our familiar dark theme. This is the default settings for Android. But we can change the theme to a light theme. In this case, I'm going to specify the material light theme. I'm just going to do a quick copy paste, but you can see the code here. So the theme property at Android:style, and then it's theme material light. And we'll put a comma. And so by making this change on our activity, this is going to affect all of the controls within our activity. Now, Xamarin.Forms simply works within a single activity on Android, so this will affect all the visuals, all the controls. And right away, this is a very obvious, very powerful change. Now I have a light theme, and of course everything has been corrected. We have the right color font against a white background, and it looks nice. And if you want a light theme on Android, this is a very easy modification to make. But we can go a little bit further. We can actually create our own theme. And to do this, in our Android head project again, I'm going to open up the resources folder, and I'm going to start by making a new folder. I'm going to give the folder a name, values-v21. And we're going to add a new file here, a new XML file. This is going to hold our custom theme. Let's just do empty file, and we'll call this styles.xml. I'm going to drop in some boilerplate code, and this is going to define a new style, which is defining that this is an XML file. And we're going to create a new style named my custom theme, but we're going to derive from that material light theme that we just saw. And now I can customize individual items. In this case, we'll customize the accent color. So we now have a custom style in our values v21 folder. We can go back to our main activity and apply our custom theme. So back to our theme entry, we're going to change this from Android style theme material light, and we'll just simply reference our theme by name. So style/my custom theme. Again, that's just the name we gave in our style XML file. Make sure we save both of these. Run our application again. And now with our application running, we again see our material light theme, but notice that our highlight color has changed. This is the color we changed, our accent color, I should say. And it's now orange. You can see it's affected the switch and our slider. And again, this will be applied globally in your Xamarin.Forms application, but specific to the Android projects. And we can get a similar effect in our Windows projects as well. Now I am on my Mac, so I won't be demonstrating these right now, but I want to show you that it's still very possible. If I open up the app XAML file in any of the Windows head projects, I can define a platform-specific resource dictionary. So by defining application resources. And if you've taken our Xamarin.Forms course, where we looked at styles and resources for Xamarin.Forms, it's a very similar process, but keep in mind this is platform specific. I'm going to define a style, and I'll just give it a target type. And so why don't we use the slider as an example. And we'll define two setters. Let's go property equals, we'll do the background color, and we'll give that a value. Pick a color, we'll say purple in this case. And let's do our foreground as well. Value equals red. Now, this is an implicit style because we haven't given it a name, and what that means is that this style will now be applied to every instance of this type within this head project. So we've now customized the foreground and background colors of the slider in our UWP application. Now, the great thing with Windows is this is fairly standardized, and I can actually copy and paste this code and drop it into the other two Windows head projects as well. And just like our theming options in iOS and Android, this will apply to, well, fairly globally within that platform and apply to all instances of those controls. And so we can leverage those the native Windows styles and resources to apply some customization to our controls. Now I know this is a very quick introduction. We really just scratched the surface of each theming option. All these are really well documented, and there's a ton of great resources out there. Each vendor has really great documentation, so it's Apple, Google, and of course Microsoft. And I highly recommend you spend a little time playing with these. They're fairly straightforward. They shouldn't give you a lot of problems. We could spend a couple of hours looking at these, of course, but I want to get on to our next topic, and that's effects in Xamarin.Forms. Now let's take a closer look at Xamarin.Forms effects. So the theme APIs let us tweak colors and other properties, but the capabilities vary from platform to platform, and for the most part, they're global settings. So a theme, for example, cannot be applied to just one element. But we have another trick up our sleeve, and it turns out to be a lot more powerful and selective, and that's effects. The effects API was added into Xamarin.Forms 2.1, so you need to be targeting at least that version, and it was updated fairly substantially in version 2.3, and that's what we're discussing here today. And it allows you to attach to the native control and the renderer to make changes to the control's visual properties. And it can be applied to individual elements or to groups of elements with Xamarin.Forms styles. Now, you'll most commonly use it to adjust visual things, but it's actually a really capable, really powerful set of APIs. Because the effect is an intermediary object that knows about and has access to the native control, the renderer, and the element, it's really powerful. It can inject new features. It can handle notifications that the default renderer does not, or even add new native visual elements into the screen. This is a really powerful API, so let's see how it works. So what exactly is an effect? Well, it's a platform-specific class that resides in the platform-specific project, and it can use the native APIs to change the appearance and behavior of the native control created by the Xamarin.Forms renderer. Now recall our picture of how the rendering system works. We have a Xamarin.Forms element that represents our control in the shared code, and a renderer that takes the element and creates our native control. The effects API adds to this picture. The renderer will create the button and pass it over to the effect. The effect can then examine the created button and make changes to it. It can't replace the button, and it can't force a different renderer to be used, but it can do almost anything else. And so in this case, we adjust the layer properties in iOS to generate a nicer, semi-transparent, blurred drop shadow, which becomes our actual rendered visual. Now when creating an effect, the author will need to create an effect for each platform that they wish to support. and each class may be implemented differently depending on the available APIs. So keep in mind that not every platform has the same features, and it's very possible that one platform might be able to provide a specific effect that another platform cannot. On the Xamarin.Forms side, effects are represented by an abstract effect class, and this is the shared representation of the native platform specific effect. And Xamarin.Forms has been updated to make working with effects as easy as possible. So every Xamarin.Forms element now has an effects collection exposed through a property simply named effects. Now notice it's an iList of effect objects, and this makes managing effects on an element relatively straightforward. We can simply add and remove from this collection. So how does the shared Xamarin.Forms code find the platform-specific effect? Well, it's resolved by a unique ID defined in the platform-specific code. And the ID consists of two parts, the company name and the effect name. So to apply an element, we need to resolve the effect. And this comes down to an effect resolution API. And the simplest way to create an effect is to use the static effect.resolve API and pass in the effect identifier. Keep in mind that not every platform has the same features, and it's very possible that one platform might be able to provide a specific effect that another platform cannot. So to make this simple, the effect resolve method always returns a valid effect, even if it can't actually resolve the name for the running platform. And so in these cases, it returns a null or dummy effect, which does nothing but doesn't cause a runtime failure. And to apply the effect, we add it to the element's effects collection. Now keep in mind when working with the effects that they are by nature visual. And when you get an effect back from the resolve API, it's the real instance of the platform effect that can then be attached directly to a single element. That means you cannot add the same effect instance to two different elements. And if you think about the properties on the platform effect, this kind of makes sense. It has a direct reference to the element it's tied to. So to use the same effect on two elements, you'll need to resolve the effect again. And effects can be removed from an element by taking them out of the effects collection, either by instance, index, or by clearing the list. So I'm going to show you how to add an effect to a project and then consume it in Xamarin.Forms. So I've got some pre-built assets, and I've actually got an effect that's been designed for each of our head projects, and this effect is going to apply a custom font to a label. And I have a custom font here as well. So let's do that first. Let's add this custom font. I'm going to bring it into each head project for simplicity. I'm going to move this window off screen, but you'll see me drag it in. And let's do Android first. On Android, this is going to go into the assets folder. We'll just drag this in, and we'll copy that. And we want the build action to be Android asset. And you can see it's defaulted to none, so we'll correct that now. And in our iOS project, we're going to bring this into the resources folder. And we see it down at the bottom. And we want the build action in this case to be bundle resource, and that has been set automatically correctly. And on Windows, we'll also add this in to the assets folder. I'll bring this in. And we'll copy that. And the build action needs to be content. Now, if you do this on Visual Studio, that should be set correctly by default, but it's always worth double checking. Now, before I bring in the effect, there is one quick step I need to do in the iOS head project. I need to edit the info plist. Specifically, I need to tell it that we're going to import a custom font. We have one included. So we're going to add a new key. I'll use a drop down. I'm looking for fonts provided by application. In Xamarin.Forms, Xamarin Studio, I should say, we could drop down lists. In Visual Studio, you need to edit the XML by hand. And this will be an array of strings, and I need to just simply give the font file name. So it's going to be Pacifico.ttf. And this is just to let iOS know that we're going to be using a custom font. If we don't, then we won't be able to see it within our application. Now my next step is to bring in my Xamarin.Forms effect, and these are pre-built, and I've got one for each project. And you might notice that there's only 4 and not 5. It turns out that the RT version, we actually use the exact same code for Windows 8 and Windows Phone 8. Those are the RT variants. I'm going to bring in the Android and iOS versions here for the projects that I can test against. And so, of course, you'd simply bring these in and add them to the appropriate head project. And here's our custom effect for Android. I'll bring one in for iOS. And for completeness, we'll add one to our UWP project here as well. Now we have the effect code in place, and we're not going to look at the code just yet, but we will make use of it. I happen to know what the effect ID is, so I can now jump over to our common code, to our portable class library, and I can resolve that effect. And I'll do that in our main page, .xaml.cs, but I want to show you briefly the XAML file. You can see our controls defined here within a stack layout. So again, there's our label, our switch. And our first label here has a name and it's label welcome. And so let's apply our custom font effect against our label. So we'll go to our main page, XAML.cs. And I'm going to create a class level field for our effect. Subtype effect, and let's call this font effect. And then let's, in our constructor, resolve it. We'll get a reference to our effect. So we're going to use the static resolve method. And for our effect, I happen to know the ID is Xamarin.CustomFontEffect. And this will resolve the effect. And again, if there was a typo here, I hadn't added those effects, this would safely return a null effect, and we wouldn't have a runtime error. We wouldn't see the effect being applied. And now we can go ahead and apply it to our label. And label welcome, the effects collection, and I simply add this effect to that collection. And we'll just pass in font effect. Now, if I run this, we can see the effect, or the font, I should say, applied to our top label, and that's quite dramatic. Now let's try one last thing, and we're going to toggle the effect on and off using our switch. And I already have the switch toggled event handler method set up in my code behind in my XAML.cs. And there's a few ways we could do this, but I'm going to just remove the effect. I have the field. I'm going to remove it from the effects collection. And then we'll check the switch state. Switch effects. If it's toggled, we'll simply re-add our effect. And we'll run this application one more time. And again, we see our font effect. If I turn the switch on off, you can see it goes back to our default font. Again, quite dramatic. And this, of course, will now work on all 5 of our head projects, all 3 of the Windows projects and the Android project. Specifying an effect by name is simple, but it's error prone. What if you misspell the effect name? Also, calling static methods is, while technically possible in XAML, let's be honest, not very much fun. So there's an alternative way to resolve effects. This is through a built-in class named routingEffect. The routingEffect class has a constructor that accepts a string. The string is the effect ID that we saw earlier. Now, under the hood, the routingEffect will resolve the effect when instantiated. So by creating a derived class in your shared code from routingEffect, you can define a specific type that represents your platform effect. The base constructor is then given the effect name to load, and routingEffect will pass through to the real effect. The benefit of this is that we have a real type to instantiate and apply, which we can then use in code or markup. And we no longer need to manage string literals to resolve the effect. And here you can see we can also use property element syntax to apply the routingEffect in XAML. So I'd like to make a routingEffect for an effect I added previously. I've got a custom font effect that can be applied to a label in each of the head projects. And it has an ID of Xamarin.CustomFontEffect. So we'll go back to our shared code, our Xamarin.Forms portable class library control. Explorer, and I'm going to add a new class. And let's give it a meaningful name. I'm going to call this label font effect. And to define a rooting effect, I need to derive from rooting effect. And this does require the Xamarin.Forms namespace using statement. And all we need to do is call the base constructor with our effect ID. And again, we can check the source code or potentially check with the author if they haven't provided a rooting effect with a supplied effect. So there's custom font effect, Xamarin.custom font effect. And that's it. And we can now instantiate this class, and this will correctly resolve our custom font effect. But what's really exciting about this is we can now apply this in XAML. So I'm going to head back to my main page XAML. You can see here we have a stack layout and a number of controls. And if you're watching earlier, we applied the effect programmatically to our label welcome. We have a second label here, and it doesn't even have a name, so we're going to apply the effect here right in the XAML. Now it turns out we can reach our effects collection in XAML, and then we can simply add effects here. Now I do need an XML namespace to reach my effect. Let's do that here, XML-NS, and I'm just going to call it EF, and CLR namespace. Now this is the namespace of our rooting effect, so in this case it's just Control Explorer. And now, with a little luck, the IntelliSense will pick it up, and there it is, our label font effect. And that's all there is to it. Rooting effects are fairly quick to create, and they're nice and easy to apply in our XAML. And here we see our application running on our Android emulator, and we see our effect applied to both labels. And again, our switch is wired up to toggle it on our top label. But we can see here the second label, the effect has been applied in our XAML. Now that we know how to consume and apply an effect to an element, let's look at creating our own effects. So first, an effect is just a class. It derives from the base class platform effect. And it doesn't have to be exposed outside of the platform assembly, and it's good practice to make it internal to the assembly. And this is the default if you don't specify a visibility for your class. The platform effect class has properties and virtual methods to let us manage the effect. There are 3 properties which we can use to get to the 3 players in the rendering system. First is the renderer. It's exposed through the container property. Second is the generated control, which is exposed to the control property. And third is the Xamarin.Forms element, which is exposed through the element property. Each supported platform, so iOS, Android, and all of our Windows variations, they define the platform effect base class in each of the platform-specific Xamarin.Forms assemblies. Now what's interesting about this is that the container and control are both generic. In other words, effects are not directly tied to a specific element type or native control type. They are intended to be used on any element. Now you can write an effect that is specific to an element or control type, but it's up to you and up to your code to actually ensure that it's being applied to only that element and ignore it if not. The platform effect class also includes 3 overridable methods. OnAttached gets called when the effect has been added to an element. OnDetached is called when the effect is removed. And the optional onElement property change is called when a property is changed on the Xamarin.Forms element or the native control. When the effect is added to an element and the native control is generated by the renderer, the effect will be created and the system will call the onAttached override. Now this is the initial point of interception for that effect, and it can adjust the starting properties for the effect or hook any notification it needs for the element, or control and manipulate whatever visual properties it needs to change and apply the effect. So here you can see we're setting the shadow layer on an Android view. And this is possible on any Android view, so this effect is completely generic and it has no dependency on the Xamarin.Forms element. In our example earlier, it was a button, but it would work equally well on our box view or entry or label. And this is how effects are intended to work, to be applied to pretty much anything and to be reusable so we could package them up in a library and use them in multiple apps. And if you're writing an effect that can only be used with a specific element type, you would test the element property here to ensure it's the correct type and then just ignore it, return if it's not supported. If the effect is removed from the element at runtime, it will get a call to onDetached. And this is your opportunity to reset any properties, unwire from any notifications, and generally reverse anything you've done with the effect. Here in our Android implementation, we're just turning off the shadow. Now finally, the effect can also be influenced at runtime by properties changing on either the native control or the element. For the native control, your effect would be responsible for adding and removing the notification as part of its onAttach and onDetach method implementations. But for element property changes coming from Xamarin.Forms, your effect is automatically wired into the built-in property change notification system that the binding infrastructure uses. So you can simply override the onElement property change method to see all property changes as they happen. So first, make sure you pass on to the base class, and property names arrive as strings. Now you can use bindable property definitions to avoid hard coding values, and you can cast to more explicit types when specific notifications arrive. So here, for example, we are fairly certain it's a visual element because we got it, an isEnabled property change, and this would break if someone declared a new isEnabled property and didn't derive from visual element. But that's not the case with anything defined in Forms today, so it's pretty safe bet. Now this approach allows us to respond to things changing on the element and do something to our native control that the default renderer implementation does not. Here, for example, we're changing the opacity of disabled elements to half transparent. The final step is to associate our name that we're using to identify the effect with the effect itself. And this is actually a two-part process. Effect resolve expects two parts of the name separated with a dot. That's the company name or the group name and the effect name. Now these two parts are then defined in each platform assembly through assembly level attributes. Resolution group name identifies the first part, the company name, and this is prepended on every exported effect in the assembly. And then export effect identifies the effect name itself. Now note, these are assembly level attributes. They don't have to be defined in the same file as the platform effect, but it's common to do so. And additionally, if you have code for more than one effect, you don't need to specify the company or group name more than once. Now the export effect also identifies the effect type. This is the magic clue that allows us to specify myCompany.shadowEffect and get the shadow effect class. All right, now let's try creating a custom effect. And I'm going to create a gradient effect to be applied to buttons. Now, writing gradients is a little bit of work. We will need some platform-specific code. To quicken things up here, I've got some helper code. I've got a basic gradient code for each platform. Again, notice we have 4 classes, not 5, because we use the exact same code for both the Windows Phone 8 RT and the Windows 8 projects. We have a separate one for UWP here. So the very first thing to do is add these helper classes into each of our projects. I'm going to drop in my gradient code for Android. Grab my iOS code. And we'll grab our UWP here. And for completeness, let's add our RT to at least one of our projects here as well. Let's do it to our Windows project. Now this will be a little bit of work to set up for each project, and we'll go through each one. And let's start with Android. I'm going to close up the other ones for now, and I'm going to jump right into it. I'm going to add a new class for our platform effect. Again, new file, empty class, and we're going to call this, my button gradient effect. Now you might be thinking, don't I want to make an effect to apply to any control? Well, that's a really great idea. In general, it's a nice strategy. There are some complexities with gradients, as you'll see. And so I would recommend, if you master this code, you might want to look into having this apply to other controls. But for now, we're going to keep it constrained and just apply it to buttons. So let's get this class all set up. There's just a little bit of work we need to do. And the first thing I want to do is derive from platform effect. And you can see it can't find that name. We're going to add in a couple of usings here. Let's get Xamarin.Forms in place. And also the platform specific Xamarin.Forms platform Android. And you can see it's now finding platform, but it's a little bit unhappy because we need to override, we need to implement a couple of methods. And that's going to be unattached. We can get rid of that throw, we don't need that. We're gonna get that implemented properly. And on detached. Now I'm going to put in just one more thing here. I'm going to add a class level field of type drawable. And I just want to be able to cache off the old background before I replace it with our gradient. And we'll bring in one more using statement, Android graphics drawables. Now it's time for our gradient code. And now, of course, this is specific to our code, but this is nice, gives you a bit of framework on how you may create other custom effects. So in this case, I'm going to guard and make sure that we're actually applying this to a button. So I want to see what type the Xamarin.Forms element is. Now we can reach the element via the element property. And let's see if this is in fact a Xamarin.Forms button. And we could even guard against this if xf button equals null, we could return. Now let's define our colors. Now I'm going to define two Xamarin.Forms colors. Let's do color, I'm going to do color bottom first. And our second gradient color is going to be simply black. And let's set our top color, and we're going to pull our top color out of the Xamarin.Forms element. So we'll use the XF button reference was created, and we can get the background color. So now, again, we're in our Android project, so we need to make a drawable. That's what we're going to apply to our Android control. So we'll make a new drawable. And for this, we're going to use our helper code. That's that gradient code we brought in. Now, take a look at this. You can see we have a static gradient drawable, get gradient drawable method. It takes two color objects. Now, of course, these are going to be Android colors, not Xamarin.Forms colors. And this does the work of creating that gradient for us. And you can see if this is the actual Android platform-specific code to create that gradient. But we have a static class and a public static method that we can call to get our drawable. Perfect. Go back to our platform effect. Let's call that gradient. Get gradient drawable. Now, you're passing color top, but again, color top is a Xamarin.Forms color, not an Android color. It turns out we have a helper method here. I can call toAndroid. And that will convert it to an Android color object. I did this backwards. Let's put this right here, onto here, color top. There we go, nice and consistent. And we'll do the exact same thing for color bottom as well to Android. Now we have a new gradient. And I'm just going to set the gradient on our control. Now we've already guarded, we know this is being applied to a Xamarin.Forms button, so we feel very confident that the native control is an Android button. So I'm just going to go ahead and set it directly. So control represents our Android view, and I'm going to call set to background and pass in our drawable. So we've set up our set gradient method, but we need to do the rest of the work now to wire it up with our on attach and on detach methods. So let's go up to on attached. And we'll do, again, just a little bit of guarding. So if the element is a button, say that's false, we'll return. Then again, so we attach this effect to something that's not a button, it's harmless, it just won't do anything. So now, for on detached, when our effect is applied, let's cache off the old drawable, the old background, to our old drawable field. We'll just grab control.background. And now we're all set. We can simply call our set to gradient method. There we go. Now the other thing we want to do, we want to be good citizens. We always want to handle on detached. This is so our effect can be removed. And simply put, we want to return it to its original state. Now, there's one nice and easy way you can do this. We know that This will only be applied to a button, and we're only going to set old drawable if this is applied to a button. So I'm going to be a little bit sneaky here. I'm just going to say if old drawable is not equal null, then I'm going to set our control background back to old drawable. And just like that, and this will replace our gradient that we set up in onAttached. Now the last thing we need to do is really give our effect an ID, a name. So we'll do this using a couple of assembly attributes, and I'm going to do this outside of the namespace. Now this should be a little bit of a, raising a little bit of a flag. These don't need to be in this file. They're commonly placed with the effect, but these really could be defined anywhere. And you'll see in just a moment. So the first one is the resolution group name, or the company name if you prefer. I'm going to use Xamarin. You should of course use your own company name or some word that is meaningful to you. And the next really is the kind of the true name, if you will. This is the unique ID. And for this I use export effect. Now we need to tell it which class, or really the platform effect we're exporting. So we're going to say my button gradient effect. So again, we're giving the name. It doesn't know from the file. We have to tell it the class name. And then the unique ID, and I'm going to say button gradient effect. Now notice a couple of errors here. It's complaining just a little bit. So first, it actually doesn't know what my button gradient effect is because our assembly attribute is outside of the namespace, and we can simply just bring in a using for that. Now it's complaining about resolution group name. Now the reason for this is we added another effect earlier. Remember the custom font effect, and it's actually already setting up this assembly attribute. So we don't need to define it a second time. Now, if you have a lot of effects, especially if you have a lot of effects with code, you may even choose to define these in a common location. For our purposes here, I'm just going to comment it out, make this easy. And we're pretty much ready to go on the Android side. So let's try out. We'll set the effect on our other head projects. Next will be iOS. We're going to follow a very similar process. So I'm going to switch over to my iOS head project, and I'm going to add a new file, more specifically a new class. And we're going to call this my button gradient effect. It's the same class name I used for the Android project. It doesn't have to be though. There's no need for that. And often, notice with the custom font effect, there's this .ios nomenclature here. That's a nice thing to do on your files just to make it a little bit easier to identify which platform you're on. It's not required by any means. We're not changing the class name, but this is a nice little identifier. Let's see if I can get that to stick. There we are. So if you have multiple files open, for example, we've got our gradient effect from Android, I can tell this is my iOS project. Not required, but nice. Now let's go through this a little bit quickly. Platform effect. Now, do you remember what we needed from before? A couple of using statements. I'm going to bring in Xamarin.Forms and the iOS specific platform. Now with that, we need to implement a couple of methods. So I'm going to do this the easy way. I'm going to implement the abstract class and bring in onAttached and onDetached. And again, I'm going to follow a very similar pattern. I want to cache off the old visuals for iOS. And actually, you know what I'm going to do here too. I'm going to delete the constructor. I don't actually need it. It doesn't do any harm, but I'm not going to use it. And I'm going to bring in, I'm going to make a CA gradient layer object. And I can call this grad layer. I'm actually going to use this, specifically I'm going to use this for our gradient. We're going to hold on to this. And let's fix that. It needs the core animation using statement. And much like we did on the Android side, I'm going to make a set gradient method. And again, this is just one technique you can use. You could, even have these methods return your visuals. Now I want to cache with this gradient layer. And in this method, I'm going to clear it out. So if it exists, I'm going to use a little bit of a C#6 notation here. Actually, I'll do it the long way. I'm going to say if grad layer does not equal null, we're going to get rid of this. And we can do this right on the gradient layer by calling remove from super layer. So if this is applied to the layer, it's going to pull itself out. It's just the iOS API syntax. Now, next, I want to get a reference to the control, the native control we're going to apply our gradient to. So in this case, again, we're going to guard this to be a button only. So I'm going to cast our control, our native control, as a UI button. And again, I need to bring in UI kit for this. And again, we could just do a little bit of guarding here if we want. If this equals null, we could return. Now it's time to set up our gradient. So to do this, much like we did on the Android one, I want to get a reference to the Xamarin.Forms button. So remember this code here, I'm going to bring that right over. Get our Xamarin.Forms button. That's be reached by our element. We actually need this here. And just make sure this is a Xamarin.Forms button. I can actually delete these, the namespace has been added above. Okay, so now we're just about ready to set up our gradient. Now, the visualization is a little bit different on iOS, and we actually need to create a gradient of a certain size. And so I need to make sure that our button size has been defined, really our size ambition. So really, has it been through a rendering pass yet? Has the button been created and applied? So I just want to double check and make sure that our native button has a width and a height. And if it doesn't, I'm just going to return. All right, let's set it up. Let's go very similar to what we did before. Oh, of course, this would be equal to 0. Get that fixed. Excellent. Okay, so I want to set a top and bottom color. And actually, I'm going to show you for the parallelism. I'm going to copy and paste this from the Android code again. Color bottom, color top. And again, now I want to get a new gradient layer, and I'm going to do this using our helper code. So let's take a look at that in our iOS head project. And that is in gradient.cs or gradient.ios.cs. You can see here we have a public static method that will return our CA gradient layer. It takes in our color top, our color bottom, and also requires a width and a height, which is why we were checking for that earlier on. And this will create our new gradient layer. You can take a look at the platform specific code here. I'll jump back over to our platform effect, and we're going to call it gradient. Get to gradient layer, color top. Now, just like on Android, color top, this is a Xamarin.Forms color. I need this as a UI kit color, as an iOS color. So, and again, I can go to, sorry, I should say a CG color. The exact same for our color bottom. Helper methods are very handy. And now, of course, we'd set our width and our height. And we just did this, right? I had this right here. Here's our button width. And we'll get in our height. I think our brackets are all paired up. Looks good. There, we've got our new gradient layer. Now, on iOS, we're not going to cache off the old layer because we're just going to insert this layer on top. So I'm going to control.layer. And we're going to insert sublayer, our grad layer, and off we go. Now again, we want to make sure that we're good citizens, and we set up our effect now to both be able to be added and removed. So we'll start with onAttached, and just like we did previously, we're going to make sure that our Xamarin.Forms element is a button. We're going to put in that code. So I've jumped over to the Android code. I'm going to copy this. It's the exact same. Look at that. Make sure our element is a Xamarin.Forms button. If it's not, then I'm going to quit. And otherwise it is, I'm going to call set to gradient. Now again, set gradient is going to go through, create a gradient layer, and add it to our native control. Now on attached, it's actually look fairly similar. I'm just going to make sure that our gradient layer has been set. So if it's not null, I'm just going to remove it from the super layer. So when on detached it's called, our gradient layer gets removed and our control is back to its normal native visualization. And of course, just like on Android, we need to set the effect name, and it's going to look very much the same. In fact, I'm going to copy and paste it. So I'm going to go back to our Android grading effect. And again, all we need is the export effect because our resolution group name was already set in our custom font effect. Let's paste that in. I'm going to close the other files, clean this up a little bit. And let's just resolve that. We'll bring in our using control Explorer to iOS. And there we go. We're all set on the iOS side. Next, we'll do a Windows effect as well, and we can see all of our platforms. Okay, so let's create our platform effect in our UWP project. So I'm going to add a new file. Now, because it doesn't recognize the project type, I don't get the nice class helper. But that's okay. We can do that fairly quickly. So I can call this my button gradient effect.cs, and we could also rename it to put that .uap in there as well. Let's set up our class. I guess first we'll do a namespace and call this control explorer.uwp and public class my button gradient effect. And right away, let's derive from platform effect. Now, because it does recognize the product type, I won't get all the helpers here, but I'm going to bring some using. So Xamarin.Forms. And for UWP, this will be Xamarin.Forms.platform.uwp. Now, just like our other platforms, we need a couple overrides. On attached. And let's do on detached as well. Now, this version is going to look a little bit more similar to the Android variant than the iOS variant. So I want to have a way of caching off the old visualization again. And for that, in Windows and Windows World, that'll be a brush. So I'm going to cache off the old brush for our button. And I'm going to bring in a little bit of helper code here as well. You remember on the Android effect and the iOS effect, we were converting from our Xamarin.Forms colors to our native colors. We had that, especially on iOS. Have a look here, as a reminder. We had that really nice little 2CG color, for example, really helpful. We actually don't have those yet in Windows, at least not at the time of writing. So I've got a little bit of code here to do that for us. Let's bring it over, and all it's doing is taking in the Xamarin.Forms color and then creating a Windows UI color from the alpha, the red, the green, the blue values. Nice and simple. So we'll use this as our helper to get our native colors. Now, just like we did in other platforms, let's create a, you know what's coming, set gradient. Now, while I'm typing here, I'm just going to say I'm not going to do this for the other two Windows head projects because they're just so similar. It's almost the exact same code. Just some very minor differences between the UWP APIs versus the RT. Really, really similar. So again, I'm going to get the Xamarin.Forms button. I'm going to cast the element. And I'm going to get the native button as well. And this actually is a little bit funny. I'm going to get a Forms button. And Forms button is a lightweight wrapper around the native Windows button. So it really is a native button representation, but this is a little class wrapper around it. But this is what we want to interact with to extract our colors correctly in our platform effect. And you know what? I'm going to copy and paste this code here. Our color bottom, our color top. I'm going to paste that in. And again, just like we did before, I'm going to use that gradient helper code. I'm going to head on over. We have a public static class called gradient with a public static method called getGradientBrush this time for our UWP project. Very, very similar code on the RT side. Returns a linear gradient brush and again takes a color top and a color bottom. Exactly what we need. We'll head back to our UWP effect. And I'll do this in one step here. Button background color. We set the background color on our native control. This is our lightweight wrapper, Forms button. We're going to set the background color property. And we'll use our gradient class called getGradientBrush. And now we don't have those built-in extension methods, so I'm going to use this getWindowsColor to extract our Xamarin.Forms color, to convert our Xamarin.Forms color to our Windows UI color. So again, let's go. I think we want to do top first. And color bottom. Perfect. There we go. Got our set gradient method all ready, creating our brush, applying it to our control. Now let's just wire up on attached and on detached. So, just like we did before, let's just guard and make sure that we're only applying this to buttons. Again, you could, with a little bit of work, easily extend this code to other controls. For simplicity, we're going to guard for now. So if we don't have a button, we're just going to return. Now we're at the native button, the Windows UWP button as a Forms button, and that lightweight wrapper. And let's cache off the old background brush. So old brush equals button dot background color. And then we just call set gradient. This will apply our new gradient brush onto our native control. On detached, again, very similar. Let's just see if that old brush exists. If it doesn't, we'll return. If it does, again, let's just grab our native control and then set that brush back to normal. Background color equals old brush. And again, almost identical for RT as well. Okay, we're all set up in each of our head projects. Let's go consume our effect. Let's close this down. I'm gonna head back up to our common code, our shared code, our portable class library, Control Explorer. And quickly, I'm gonna make another rooting effect for our new effect. It's generally good practice and it makes it a little bit easier to consume. So I'm gonna make a class called button gradient effect. I'm gonna derive from rooting effect. I'm gonna move quickly here. You've seen this before. Bring in Xamarin.Forms and call the base implementation, the base constructor, with our full name, Xamarin dot, what was that again? Oh, right, export effect button gradient effect. Xamarin dot button gradient effect. And so now, of course, we could consume this in XAML, but I'm actually going to do it in our code behind. Now, let's sneak back over to our main page.cs. I'll show you how we can use our rooting effect and how it's a bit easier than calling resolve with the full ID. And I'm actually not going to apply our effect to our button in the constructor. I'm going to do it on appearing. Do you know why? Remember way back here in iOS. Let's go back to our iOS effect. Oh, this is the Android one. Let's go to our iOS effect here. I'm going to pull this up, make sure this is clear. Now, this is a little bit specific to this effect, and this will not affect all effects. But for visual things in iOS, this is worth keeping in mind. This is coming back to understanding the native APIs and the native OSs. Remember we set our gradient in iOS. We needed that width and height. Our native control needed a width and height, and that means that our native controls need to be laid out. And what that means from a Xamarin.Forms perspective is that we have to go through a rendering cycle. Our control's been laid out and are now visualized. And so we feel very good about that in our on-appearing method. In the constructor, we haven't been through a rendering pass. Initialized component means our controls have been initialized, but they haven't been visualized, so they haven't necessarily been given a size and a shape. So to make sure that we have our control in place, I'm gonna, well, you know what I'm gonna do? I'm gonna go override on appearing, and I'm going to apply our button effect here. Now our button name happens to be button click. It's just not an overly creative name, I know. We're going to use the effects collection and call add. And instead of doing that resolve, now I'm just going to new up our rooting effect. And this is really nice. Even programmatically, the rooting effect is very nice. Button gradient effect. And there we go. We have a nice type-safe way of applying our effect in code. All right, let's take a look at that. And because of all that talk with iOS, let's run it on the iOS platform. And here we see our application. It's really changed quite a bit from our initial plain version. And we see this very nice blue to black gradient on our button. Now let's talk about customizing our effects. Now sometimes an effect needs no further information, or it can figure everything out from existing properties on the element or the control. But often we would like to provide customization to that effect, especially if we want to reuse this effect in other applications and other projects. But we can't just add properties to the platform effect because we're relying on a dynamic resolution to locate and create it. So imagine an effect that adds a drop shadow. What properties might you want to configure? Maybe size of the shadow, the color, angle, or transparency. These are all common things to configure in a shadow, but they're not provided on any Xamarin.Forms elements. And one option is to add public properties to the routing effect derived class, and this is a convenient place to add properties in the common code. And to access these properties is a bit of work, since they're defined on the routing effect in our platform effect class in our platform specific projects. We'll need to access the Xamarin.Forms element and then search for our routing effect in the effects collection. The solution does work, but it has a couple of drawbacks. As we just saw, it's a bit cumbersome to reach the properties, and you're not able to use two instances of the same effect on a single element. This may be unlikely, but it does mean that we're restricting our usage. But finally, and most importantly, the routing effect has no way of notifying the platform effect if the property is updated. This means that this strategy is only useful for properties that you're not planning on changing at runtime. So what we really need are properties that we can set onto the element where the effect is being applied, and then be able to read those property values from our effect. Xamarin.Forms has a feature which supports exactly this scenario: attached properties. And these are special bindable properties that we define somewhere. In this case, we can put them onto our shared code representation of the effect. This is the one that derives from the routing effect. Now, attached properties are global properties that are settable on any object. This allows external properties to be added to an object. This is covered in more detail in Xamarin.135. So you'll need a reachable static bindable property, as well as public getter and setter methods to read and write the property. First step is to create the bindable property by calling the static createAttached method. Although you'll pass in the property name as a parameter, with attached properties, the name of the bindable property is used for the identification. And you'll also need to specify the return type. This is the type of data that the property will hold. Now, the declaring type sets what type the property can be applied to, really where you're attaching it, and a default value in case the property isn't set. And we also need getter and setter methods, and these are used to read and write the attached property. Notice the call to set value in the setter method. This is how the property is associated with this specific object, or view in this case. And in the getter, we use the getValue method to retrieve the property for that specific object or view. We can then use this new property to set values onto the element where we're adding our effect. So setColor in this case is our static setter method. We pass in the view we want to associate with the property and the value to be stored or attached. Attached properties can also be set in XAML as seen below. The platform effect can then monitor these properties just like any property defined on the element itself. And this makes the onElement property change method even more powerful. Here you can see we're looking for our custom color property and adjusting the shadow color when we see it change. Okay, for our final bit of coding, we're going to modify our gradient button effect and allow it to update and set that second color. Remember, we hard coded it to a black. Now we're going to set it so we can change that color based on the slider position. And to do that, we're going to need to create an attached property. To do that, we're going to open up our routing effect for our button gradient effect class. And let's create a bindable property. Make public, make static, and read only. Make a bindable property. And let's call this gradient color property. You can see the IntelliSense is helping me already. This next line for visibility. We're going to use a factory method here, createAttached. Now, we've got a few overloads here. I'll go through this very quickly. First thing we do is give it a name, which we actually don't use in this case when we use attached properties. We'll still give it a meaningful name, gradient color. Now next is the type. So what is this? Well, it's a color. This is a Xamarin.Forms color, so we'll give it the color class. And then we need to set what it's going to be applied to. And we want to apply it to our button gradient effect or our routing effect. And the last value we need is a default color, and I'm going to call this just color.black. We'll default it back to that black color, just in case we forget to set this. Now we just need our setter and getter methods for our property. We'll set those up. Again, those will be public and static. First is our setter. We're going to call this set gradient color. And we'll pass in a visual element, our view. And our color, I'm going to set our gradient color. Let's call that color. Now look when we're actually applying this. We're going to apply it to the view. Call set value. I'm going to use a gradient color property. That's our bindable property. I'm going to set it our color. Now let's create our getter method. Again, it's going to be public. It's going to be static. And this time it's going to return the color. Again, that's the Xamarin.Forms color. We'll call this getGradient. And we'll take a visual element again. Now we're going to call view.getValue this time. Get our gradient color property. Now note that getValue, let's see if they'll show us here. Well, it just returns an object. So we need to cast that to a color. It's as simple as doing a hard cast. And there we go, we're all set with our getter and setter methods. And now we can set our attached property. So let's go back to our code behind for our page. And we'll do this when our slider is changed. Now, I've already got a method in place that responds to slider value changed, non-slider color value changed. And I'm going to be a little bit uncreative. I'm going to use grayscales here. I'm going to go from white to black. So let's create a new color object. I'll call this grad color. And we'll loop a new color object, and we'll create this based on the slider position. Now, I cheated just a little bit. If I go to our XAML here, our slider maximum value is 255. So this is going to go between 0 and 255. Perfect. For our colors, let's go to our code behind. So I can just take the new value from our slider and divide that by 255. And I'm going to do this for the R, the G, and the B. So I'm going to get a grayscale value from 0 being black to 255, which will be white. Got our new color, and now let's set our new color. So what are we setting this against? Right, well, this is going to be our button. Gradient effect. Set gradient color. Now we set the visual element that we're going to apply this to. Right, it's our attached property. We're going to attach it to our button. Let's just button click. And then, of course, the color value, our grad color. Now, the final step is to update our platform effect, the effect in the platform specific projects. So I'm going to demonstrate in iOS, but these steps are identical for all the platforms. So let's go back to our platform effect. So my button gradient effect. And perfect. Actually, right here we have our colors. So here's our color bottom. So we've defined this to black. We've set this to black. Let's change that now. And so now I actually want to get the attached property. So our button, gradient effect. I'm going to call our getter method. I'm going to call get gradient color. What does it take? It takes our visual element. So it's going to take our button. Now, which button is this? Well, what do we apply it to? We'll go back to our code behind. We've applied it to our Xamarin.Forms visual, our Xamarin.Forms button. And that's exactly what I need to pull it back from. That's where it's attached to. So I'm going to get gradient color, and that's going to be the Xamarin.Forms button, which we've conveniently named XF button above, right? We get that from our element. And that's all we need to do. I'm going to delete this entry here. And of course, we have applied it with our slider moving, but if we didn't apply it, we set up a default value in our routing effect. Remember, we set a default value of color black. So we can't lose. We'll always get a value back. So now we're using the color, and so when set gradient is called, so when unattached is called, it's going to set the color based on, well, the slider position or the attached property. But what happens if we move the slider? Well, we're going to be able to respond to changes. And for that, we're going to override another method. I'm going to override on element property changed. We are going to call the base implementation. And now, so to make sure this is being used on a button, again, we've guarded against other controls. You could easily extend this to be more generic if you like. And I'll just say if it's not a button, I'm going to return. And now we're responding to property changes, but I'm not really all that fussed about most property changes. All I really want to know is if our gradient color has been changed, right? Has somebody called set gradient color and updated our attached property? So I can check that. So let's see which property. So let's see, what do they call this here? Our args here. So if args.property name, and so this now we're concerned about the actual name we defined on our bindable property, and this is going to be gradient color. So the name we set for our bindable property. So if that property has been changed, let's just make that a comparison, double equals. If it's gradient color, well then, well, we've been very clever. We simply just call set gradient. And again, remember, set gradient will go through, it'll remove the old layer, and then it will recreate our gradient layer in iOS. But the code is all very similar on the other platforms, and so these steps are actually exactly the same, right? We just check, make sure we're applying to a button, check the property name, and then call set gradient on all of our platform specifics. And again, when we're generating our gradient, we'll just get our bottom color for the gradient from the attached property. That's all there is to it. Let's give it a try. And here we see our app again, looking very, very decorated. Now if I move the slider, notice now that second gradient color is changing, and we're going from black to white. So we're respecting those property changes. And this will of course work on our other platforms, so like our head projects as well. And this brings us to the end of our presentation. Thank you so much for joining me here today. If you'd like more information on Xamarin.Forms effects, please visit the developer portal at developer.xamarin.com. If you have questions, you can always ask in the Xamarin forums, or use the office hour session as a Xamarin University student and schedule some one-on-one time with your favorite instructor.